Hi everybody, we are going to look at naming aromatics that have a common root. So a little reminder about our common roots. We have toluene, that's when you've got the benzene with a methyl group, that's always called toluene. Phenol is going to be the benzene ring with an alcohol, the OH, and then the aniline is when you have the NH2, that amine attached to the benzene ring. So let's say that you have your root plus one more substituent, all right? Root plus one substituent. You simply name or number. When I say name, that means ortho, meta, para, or number the root for root as the C1. What I mean by that is either the methyl, the alcohol, or that amine, say that that's carbon 1. You always start counting at that root, at the substituent unique to that root. That's your first carbon. And then you simply write down the substituent, so after you write the substituent, then you're going to write the root after the substituent. Sorry, I should have put right substituent right there. So let me show you. This will make sense when I show you. So my first example, notice I have a toluene. I recognize a benzene ring with a methyl, and I go, oh, I've got that memorized, is toluene. Now there's a bromine attached to the toluene. So I count as this methyl group attached to the carbon 1. That'd be 1, 2, 3, 4. So you can name it one of two ways. You can name this para, where we're on the 1 and the 4, that's the para, or I could just say 4. So this is para-bromotoluene. So there's my substituent. Where it's located, it's at the para or the 4. It's called bromo, and then it's attached to this aromatic called toluene. Now let's look at number 2. I see my benzene ring with an alcohol group, the OH, and right away I go, oh yeah, I have that memorized. That's a phenol. So the carbon attached to the alcohol, that's carbon 1. That's where I start counting. And then we always want to give our substituents the lowest number possible. I would never do this. I would never go 1, 2, 3, 4, 5, 6. I would go 1, 2. Give it the smallest number possible. So one of two ways to name this. We can name it 2-chlorophenol, or because they're right next to each other, the 1 and the 2 carbons, it could be the ortho. That could be orthochlorophenol, either one of those. Let me come back here really quick. So you're going to name or number the root as the C1, and then I'm going to you're going to name or number the substituent accordingly. Substituent. Okay, so based on either the methyl, the alcohol, or the amine, that being a carbon 1, what is the position of the substituent attached to that root? Okay, so 2 examples there. Now, let's say that we have 2 or more substituents attached to one of these 3 roots. So first you're going to name and number the root as the C1. So it's going to again be that methyl, alcohol, or amine, that gets the number 1 position. You always start numbering with that, number 1. Then you're going to write the substituents alphabetically, so don't worry if the numbers don't go in order, ascending order. You always write alphabetically, and then you just write the root name at the end. So I have 3 examples for you on this. I noticed that NH2, that amine, I go, oh, I have that memorized. That's aniline. When that NH2 is attached to a benzene ring, that's aniline. And then I see 2 chlorines. So the carbon attached to the NH3 is my 1. And I'm going to count and see how can we give the smallest numbers to our substituents. Let's go clockwise. We'd have 1, 2, 3, 4, 5, 6. So 3 and 6. Let's go counterclockwise. There's my 1. 1, 2, 3, 4, 5. So going counterclockwise will give us the smallest numbers. So we will have a 2, 5 dichloro, they're both chlorine, dichloroaniline. Aniline, because that's the root. That NH3 is the benzene, is the aniline. Again, 2,5-dichloroaniline. Let's look at our next example. Ooh, I see the methyl group, that CH3 attached to our benzene. And so I go, oh, I have that memorized. That's toluene. Now we're going to count. We want to give those smallest numbers to the substituents. Let's go clockwise. 1, 2, 3, and 4. 3, 4, or here's my 1. Remember that whatever defines that particular root, that's where you start on the 1. So this methyl, I start at 1, 2, 3, 4, and 5. So it's going to give us the smallest numbers to go clockwise. We have 1, 2, 3, 4. Label these alphabetically. So bromo comes before chloro. 4-bromo, 3-chlorotoluene, because the toluene is a benzene with that methyl group. Nice. Okay, last one right here. I look and I go, oh, there's an alcohol attached to the benzene. That's called phenol. I have that memorized. So the carbon attached to the alcohol is your 1. Always start. That's where you count at your 1. And let's count clockwise. We'd have 1, 2, 3, 4. If I go counterclockwise, we'd have 1, 2, 3, 4, 5, 6. So 4 and 6, those are bigger. Let's go clockwise. 2, 3, and 4. So 2 and 4. Going to name these alphabetically. I have a fluoro and a propyl for my substituents. So it'll be 2-fluoro, 4-propyl, phenol, because the alcohol is attached to that benzene. Nice. And there you have it. When you have those common roots, make sure that you have those roots memorized, and then you begin your numbering based on those roots for the substituents. Okay, good job. Hit that like button if this is helpful, and have a wonderful day. Thank you. Bye.